Now in this video, I want to take a look at how we can use these programs for TI-89, or for any other calculator. The programs are the same. Okay, to solve these two problems. Now here, as we saw earlier, this is the same problem we saw. Okay, we're trying to find the point of intersection between these three lines. So I'm going to take these three lines. We're going to feed them into the calculator here. Okay. So again, let's take and find the intersection between 2x plus y equals 14, 3x plus y equals 22. So they're all lined up in this ax plus by equals c. So 3 goes in as the a coordinate, then 1, then we got 22. Okay. And then we're going to feed in these values. That would be 2, 1, and 14. And so we now tag this point of intersection as 8, negative 2. Tell you what, let's just color code that a little differently. So this is going to be 8, negative 2. That's now one of the points. Okay, and now let's go and pull this calculator back up again. Let's run through the program again. So we got to go home and execute it again. Now let's find this point right here. All right, so that's going to be intersection between those two lines. And so again, we're going to go with 3, 1, 22, and then we'll go with 1, 1, and 8. Okay, and then that would be the intersection there is 7, 1. So we got the intersection here, 7, 1. Now again, these lines were just arbitrarily graphed just so we could have something to reference here. Okay, go home again, and one last time. Let's go 1, 1, 8, 1, 1. Nope, 1, enter, 1, enter, 8. Okay, and 2, 1, 14. Then 2, 1, and 14. Okay, and there we find negative 4, 12 as this point of intersection. So we're going to label that negative 4, 12. Negative 4, 12. Now, okay, we've actually are done with that. So now we want to find the equation of two of the perpendicular bisectors. So we have that Purvis program. So I'm going to come back and go to my calculator, go home. My program here was, I think I just called it PB. So, but again, if you forget where the programs are, there's a variable link that we look for them. We scroll down, okay. We try to find the program we're after. If we don't remember its name, we'll find it there, okay. And there's mine, PB, I've called it, okay. Close the parenthesis. Remember how what this is going to ask for is the equation is going to ask for the points on the. In this case, we're going to plug in negative 4, 12, and 7, 1, and find the equation of that perpendicular bisector. So, so then let's put that down. Okay, so we're going to feed in 4, and up. That's going to be a problem. So I'm just going to feed in anything because I put in the wrong values. Okay, so I'm going to just go home and execute that program again. So those things happen. Okay, so it's a negative 4, 12, and well, it looks like we have a problem. Input CD. Oh, I'm going to have to. Okay, we're back. Now we're going to run the perpendicular bisector program. We're going to find the point, the perpendicular bisector. In this case, this blue line. I already executed it, and I'll execute it again just to illustrate for you. Okay, and so our point is negative 4, 12, and then 7, 1, and we end up getting this equation, which is 11x. I have to pull that back up. Okay, and see it again. 11x minus 11y. I think that said equals 55. Okay, that's the one perpendicular bisector. And my only problem is that this keeps going back and forth. It looks like it's a negative 55. So I'm going to put that in there. Negative 55. Bring this back. Okay, now let's go home and execute this again between 8, negative 2, and 7, 1. Okay, so I'm going back between 8, 8, negative 2, and 7, 1. Right, 7, 1. That would be it. Okay, and then that equation looks like negative 1x plus 3y equals negative 9. Negative 1x plus 3y equals negative 9. Negative 1x plus 3y equals negative 9. Now all I have to do is one last time here, execute and make sure I got that. Negative 1x plus 3y equals negative 9. Now go back to the symbol program. Go back. I can come back up here. It's still there. Okay. Enter it there. And then I'm going to put in 11, negative 11, and negative 55, along with negative 1, 3, and 9, and that should about do it. So it looks like I'm finding negative 3, 2 is my point of intersection, my my center of the circle, negative 3, 2. So let me write that down. Center is negative 3, 2. Well, you know what? I might as well just find the distance, execute this distance program between that and any one of those points up there, and just find the center of the circle. So let's go and go home, and let's call on this distance program again. Let's track it down to see where it is. Okay, variable link, and scroll on down, get the distance, because that'll be our radius. Okay, there it was, and our distance is going to be between, let's say we're going to go between negative 3, 2, negative 3, 2, and any one of those points. 7, 1 will do. 7, 1, and that looks like 10.05, we'll call it. So then we can write down the radius is 10.05. So radius is equal to 10.05, and so I guess our equation of our circle is x plus 3, quantity squared, plus y minus 2 is equal to 10.05 squared. Okay, so there it is. All right, so we used our programs. Okay, on the calculator. We used 3 programs to solve this problem. All right, now it probably took me a little longer because I'm trying to explain things to you than it should take you in doing that problem with your calculator, but there it is. Okay.